Welcome back to my YouTube channel. So in this video we're going to be talking about oxidation number. So why should we learn oxidation number? We will learn oxidation number, or oxidation number is very important in naming compound. You cannot name compound without its oxidation number. So oxidation number is very necessary. So let's do some oxidation number. But before we do about oxidation number, before we solve problem based on oxidation number, you must know the first 20 elements and the group they belongs to. So how to know the group they belongs to? So this is the periodic table. So how can we use this periodic table, and how this periodic table relates to oxidation number? So in the periodic table we have groups and we have period. So discs like this are called period. Why these are called period and these are called group? So elements here belongs to group 1, group 2, group 3, group 4, 5, 6, 7 and 8 or 0, or you call this the number gas because they are stable. So hydrogen belongs to group 1. And how can we know elements that belongs to groups? And how without using the oxidation number, how will you know whether this element belongs to group 3 or group 4, or maybe you have crammed it but you cannot remember? So let's go back to our first 20 elements. Let's go back to our shares. So we have KLMN share. We have the first share, the second share and the third share. I also have the fourth share. So these shares, you have the KML and shares. So the K share can contain only 2 electrons. So if these 2 electrons is complete, it will be classified on the noble gas structure. As you can see here, we have hydrogen. Hydrogen only has 1 electron. That is why it is classified in group 1. This is the valence electron of hydrogen, so that is why it is classified as group 1 elements. But let's talk about beryllium. As you can see here, beryllium is in group 2. So let's write beryllium. Here is beryllium 1, beryllium 2. So 1, 2, 3 and 4. You see that this share, the K share, is completely filled with electron. So you have the KMNL share. So as you can see in beryllium, the beryllium have 4 electrons, and this K share can only contain 2, and it has been completely filled up. So this L share can contain 8 electrons, so it has 2, so remaining 6. So this remaining 6, so we call these 2 electrons the valence electron, because these are electrons that is in the atmosphere of these elements. This is the atmosphere of these elements. The L share is the atmosphere of these elements, because this is the highest energy level of these elements. So that is why it's classified in group 2. So if you're talking about helium, helium only has 2 electrons. So these 2 electrons completely filled up the K share. As you can see here, it's completely filled up the K share. So it will not go into reaction because it is filled up. It doesn't need to lose or gain electron. So group 1, group 2, group 3 are generally metals, and they are very reactive. They give out electron while the non-metals receive the electron. So I think I've laid a basic understanding about this periodic table. As you can see here, sodium, if you count sodium, you have that sodium is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sodium here is 11. So if we decide to place this electron, let's count sodium 1, sodium 2, 3, 4, 5, 6, 7, 8, 9, 10. So sodium remain 1, which is this 11. So it has only one valence electron, as you can see here, in its atmos share. So that is why it is classified in group 1. If any element should have 3, as you can see in aluminium has 3 in its atmos share, so that is why we're going to classify it as group 3 elements. So let's go over to our main business. So let's find the oxidation number. You know, why are we looking for oxidation number? Oxidation number is very necessary for naming of compound. As you can see here, this is potassium triazochlorate. We don't know what next to pronounce, so for us to pronounce this compound accurately well, what we have to do first is to calculate the oxidation number or find the oxidation number. So let's go back here. As you can see here, oxidation number of potassium is 1. Oxidation number of oxygen is -2. So let me show you how to do this oxidation number. So here is +1, here is +2, here is +3, here is they can receive and they can lose. We are going to treat this group 4 separately. So let's go over to group 5. So this group 5, we are going to write -3. Reason, they have to gain 3 electrons to obtain this noble structure. They have to gain 3 electrons. So oxygen, so elements in group 6 are -2. They have oxidation number of -2, while elements in group 7 has oxidation number of -1, because they have to just gain 1 for them to have this noble structure. So why you put in +1, +2, +3, -3, -2, and -1? As you can see here, in electron, for electron to be electrically neutral, which means the total number of proton is equal to the total number of electron, so which makes them electrically neutral. Electron are negatively charged while proton are positively charged. So for an element, for example sodium, to be electrically neutral, which means the total number of proton is equal to the total number of electron. So for this sodium to have +1, as you can see, for this sodium now to have +1, which means that the total number of proton is 1 greater than the total number of electron. For this to have 1, which means it have lose 1 electron, so the proton charge, the positive charge, will now overcome the negative charge. So this is how this work. As you can see in oxygen is 6, so it needs 2 electrons to become to obtain the noble structure. So oxygen has to go into reaction and gain 2. So this oxygen gaining 2 means that remember that electron is negatively charged while proton is positively charged. So for this thing to gain 2, which means that the total number of electron is not greater than the total number of proton. So for us to find the oxidation number of oxygen, as you can see here, oxidation number of oxygen is -2, because the total number of electron is not greater than the total number of proton. So let's count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what was oxygen here? Oxygen here was 8. Oxygen here was 8, which means it has 8 proton and 8 electron. So oxygen we go and gain more electron, having -10 electron and 8 proton. So -10 plus 8 will now give us -2, which means oxygen has more -2 electron. It has gained more 2 electrons, so this charge will now come out to -2. So this is how this oxidation number work. So let's find the oxidation number of this. Let's go back to our periodic table. Potassium is 1. So what is chlorine? So here chlorine is what? -1. What is oxygen? Oxygen is -2, but times 3. So let's find. Well, we're not going to find for chlorine. Why are we not looking for chlorine? Because chlorine is what we are looking for. So to calculate the oxidation number here, potassium is +1 plus chlorine as what we are looking for, plus oxygen. oxygen is minus 2 times 3, which is equals to 6, which this is equals to 0. If there is no charge, which means this compound is equals to 0. But if there is charge, which means this compound is equals to that charge. Let me say here is plus 1, which means in finding the oxidation number here, when we are done calculating for this side, we are going to equate it to plus 1, because here was plus 1. So finding the oxidation number here, we have plus 1 plus chlorine plus minus 6. So chlorine will now become, take this to the right hand, we now have plus 6, and take this to the right hand side, we now have minus 1. So yeah, chlorine will now become plus 5. So but here chlorine was minus 1. Why? To tell you that we don't have a stable oxidation number. There are few elements here which have stable oxidation number, but in some cases they change, so depending on the compound. So oxidation number generally depends on the compound they are presenting, the number, whether they lose or gain electron. So here now we now have chlorine as plus 5. So to name this compound, we're going to say potassium trioxo. Why here is tri is because there is presence of 3 oxygen. If 4 was here, we're going to say tetra. If 5 was here, we're going to say penta. If 6 was here, we're going to say hexa. If 7 was there, we're going to say hepta. If 10 was there, we're going to say deca. If 9, none. Or if 8, octa. So here now we now have potassium, we have chlorate, and we have oxygen. So to name this, we have to say potassium trioxo, because oxygen is here, trioxo chlorate. Any in the middle number, we are going to remove that the last 3 words and add ate. Why the last number, we are going to remove last number and add oxo for oxygen. Let's name more. We are going to understand how this thing is working. So in pronouncing this compound, we are going to pronounce this as potassium triosochlorate 5. So let's find the oxidation number of this. So this is calcium hydroxide. So to calculate the oxidation number of calcium and calcium hydroxide, so you remember here is multiplying by 2. So to find oxidation number of calcium in calcium hydroxide, we have oxygen to be minus 2 times 2. Why? Because here is multiplying this oxygen by 2, and the oxidation number of oxygen is minus 2, plus hydrogen is plus 1 times 1, which is now 2, which is equals to 0. So here is calcium, here is plus 2 crossing over, we have equals to minus 2, and minus 4 crossing over, we now have plus 4. So here when I become calcium is equals to minus 2 plus 4, we now have plus 2. So the oxidation number of calcium here is plus 2. So here is calcium hydroxide. So let's do for potassium permanganate. So this is potassium permanganate or potassium tetraoxo manganate. What? We don't know the oxidation number, so we can't pronounce it until we have to know the oxidation number. So what is potassium there? Manganate. You pronounce it as manganate instead of manganese. Remember, if you're looking at the oxidation number for the metal compound, for the elements in the metal compound, we remove that last 3 words and add ate, manganate. If carbon was there, we're going to pronounce it as carbonate. If chlorine was there, we're going to pronounce it as chlorate. So here now we now have potassium tetraoxo manganate. What? So potassium here is plus 1. Remember the charge here is 0. So here will now be 0. We are going to equate this compound to be equals to 0. So manganate, as what we are looking for, will become X, or we can also add manganate there, plus oxygen is minus 2 times 4, because this 4 is multiplying this oxidation number of oxygen. So we now have minus 8. So minus 8 crossing over, we now have X is now equals to 1 crossing over, you have minus 1, and minus 8 crossing over, we now have plus 8. So here will now become equals to plus 7. So in naming this compound, you have to now say potassium tetra, because why? 4 was here, tetraoxo manganate 7, potassium tetraoxo manganate 7. So in this kind of question, if I want to confuse them more, I will just do some I will write something like this. This question, maybe I wanna change it to be like this: -1. So don't get confused if you see this kind of thing. Just equate it to -1. Why? Because here is raised to the power -1, and find for the oxidation number here. Here is manganese plus oxygen is -8. So here is manganese -8 crossing over, we now have what? 8 -1, we now have +7. So the oxidation number here is equal to the oxidation number here, because potassium is 1, and we equate this then to raise to the power -1. So let's practice. I think this should be the last question, so let's practice this one. And how can we pronounce this? So we are asked to find the oxidation number of copper here, which generally we know that the oxidation number of oxygen is -2. So -2, this is copper, plus in brackets -2 is equals to 0. So copper plus times minus is -2, which is equals to 0. So copper is now equals to +2. So in some cases we can also see copper as equals to +1, but for here we have that copper is equals to +2. So how can we name this? So naming this, we're going to say copper 2 oxide, but there is no 2 here. So why are we pronouncing this then as 2? We are pronouncing this as 2 because the oxidation number here is +2. In some cases, if this then was sodium chloride, as you can see, we're not going to say sodium 1 chloride. There's nothing like that, because sodium has a fixed oxidation number. So why pronounce this then? We're going to just say sodium chloride. This is a salt. So I hope you grab and understand something from this lesson. Thank you and goodbye. Don't forget to like, subscribe, and hit the notification bell for more videos like this. But we're going to be talking about redox reaction, both acidic and alkaline medium. So how can we do this? So let's start practicing some questions. So look at these two redox reactions. So we are asked to balance this. So first, what can we do to balance this equation? So to balance this redox reaction, first we're going to find which one is the oxidizing agent and which one is the reducing agent. As you can see here is the reducing agent. Reason, because iron is the reducing agent. Reason, because it is the one that is oxidized, while chlorine is the oxidizing agent. Why? Reason, because it's the one that is reduced. So solution, first what you have to do is to find the oxidation number. So oxidation number of iron here is +2, oxidation number of chlorine here is 0, oxidation number of iron here is +3, and the oxidation number here is -1. So we have to take the oxidized and reduced. Which one is oxidized? As you can see, iron is oxidized, so we're going to do iron +2 will now give us iron +3. So we're going to add electron to balance the total number of atom. As you can see here, the atom is balanced, but the total number of electron is not balanced. So to balance the total number of electron, we are going to add 1 electron, so that if you have 1 electron, so that here will be 2 electron and here will be 2 electron. So for the reducing agents, as you can see, here is chlorine, which will give us chloride ion. So here we have 2 atoms of fluorine, while here we have 1, so it's not balanced. So what we're going to do is to add 2 to balance the number of chlorine. So the total number of chlorine is not balanced, but the ion is not balanced. So here 2 times -1, which means we have -2 electron here. So here we have 0. So what can we do to balance the total number of charge? So to balance the total number of charge, what we have to do is just to add +2 electron to balance the total number of charge. So here will now become 2 chloride ion. So the oxidizing and the reducing agent is balanced. So what we have to do now is to equate them in an equation. So to equate this in an equation, we have to balance the total number of electron. So here we have 2 total number of electron, while here we have 1 total number of electron. So what we're going to do is to multiply here by 2 and multiply here by 1 to balance the total number of electron. So multiplying here by 2, we have ion plus 2, which will now give us ion 3 ion, plus multiplying here by 2, we now have 2 electron. So we have to multiply this equation by 2. And for the chlorine ion, for the chlorine, we have to multiply by 1. So multiplying by 1, we have no change. So here now we now have 2 chloride ion. So since the total number of electrons is equal to the total number of oxidizing electrons is equal to the total number of reducing electrons, so what we have to do now is to cancel out. Our aim is to balance this redox reaction. To balance the redox reaction, the electron must be in the opposite side. For instance, electron cannot be here and electron be here. So electron must be in the opposite side for this reaction to balance. So as you can see, electron is in the left hand side, while for ion, electron is the right hand side. So what we have to do now is to cancel out. So cancelling out the electron, what is remaining now is to write this in a very good half equation manner. So writing this in a good equation manner, we now have this. So you can start from ion, you can start from chlorine. Anyone is not depend on your choice. So let's start from ion. So here now we now have 2F plus 2 ion plus chloride 2, which will now give us chlorine, which will now give us 2 ion 3 plus 2 chloride ion. We have write this. You can start from 2, you can start from ion or chlorine depending on your choice. So the choice now lies on your hands. So let us check whether this is balanced. To check whether this is balanced, if the total number of charge is not equal to the total number of charge in the left hand side is wrong. So in my left hand side I have 4, because this 2 we multiply this 2, giving us plus 4, which will now give us here 2 multiplied by this time we now have 6, minus 2 multiplied by minus we now have 2. So here is plus 4 and here is equals to plus 4. So this reaction is balanced because the number of charge is equal to the total number of charge in the right hand side. Total number of atoms is equal to the total number of atoms in the left hand side. So the reaction is now balanced. So let's go back to more complex one. So look at this equation. First, what are we going to do? The first thing we're going to do here is to check the oxidation number. So to check the oxidation number here, the oxidation number here is plus 2. We're checking the oxidation number to identify the one that is oxidized and the one that is reduced. So the oxidation number here is 4. I've taught you how to calculate oxidation number in my former video. So if you don't know how to calculate oxidation number in my video, go back to my video so you understand how to calculate the oxidation number. But if you can calculate, fine and good. So here now we have equating this compound. We now have 4 times minus 2 will now give us minus h is equals to minus 1. So minus 8 crossing over here will now give us plus 7. So the oxidation number here is plus 7, while the oxidation number here is plus 3 and the oxidation number here is plus 2. So let's go ahead and balance this equation. In balancing this equation, what do we need? Let's go for the oxidation. So which one is oxidized? As you can see, here was plus 2 and here was plus 3. So the one that is oxidized is ion. So ion to the both hand side of the equation, which will now give us. So to balance this, we're going to add 1 electron so that the total number of charge is equal. So we now add 2 electron, 2 plus, which will now give us 3 plus 1 electron. Now we now have the third charge to be +2 and +2. For the reduction, so for the reduction we have manganese and this. So first we're going to balance the number of atoms. So from this equation, the number of atoms of manganese is balanced. So how can we balance the number of oxygen? So to balance the number of oxygen, we're going to add 4 molecules of water to the right hand side to balance the number of oxygen. You're not going to add oxygen directly. We cannot add oxygen directly unless we are solving for different something. But in redox reaction, we have to add total number of oxygen to the left hand side, to the right hand side, to balance the number of oxygen, which is here. Now we have 4 molecules, we have oxygen. So to balance the total number of oxygen here, we have to add 4 molecules of water, and these 4 molecules of water contains the same amount of oxygen here. If 2 was here, we're going to add 2 molecules of water. If 1 oxygen was here, we're going to add only 1 molecule of water. So since 4 molecules of water is here, if you check here, we now have 8 hydrogen ion. Remember that we're balancing this then in acidic medium. We're going to still balance in basic medium. So here now contains 4 times 2, which is now 8 hydrogen ion, which will now give us manganese 2 plus 4 molecules of water. So is this equation balanced? Nope. So to balance this, we're going to add how many electron? So since here is -1, here will be 8 times +1, which will now be 8, and here will now be +2. The charge here is 0. So here will now be +7, and here will now be +2. So to balance this, we're going to add 5 electron, so that the total number of charge will be equal. So here will now become 2 plus electron, and here will now become 2 plus electron. So implementing this in the equation, we now have manganese O4 minus plus 5 electron, which will now give us manganese 2 ion plus 4H2O. So let's write the, as you can see here is 5 electron, while here is 1 electron. So to balance this, we're going to multiply this equation by 5, so that the total number of electrons will be equal. So multiplying here by 5, we have that here will now become 5 plus 5 electron, which will now give us 5 plus 3 electron plus 5 electron. So this is now balanced. And how are we going to check whether this is balanced? Because this electron is on opposite side, while the water is also in opposite side of the reaction. But let us not consider for the water, because we're going to balance the water separately. I'm going to consider the water when doing alkaline medium. But since we're doing acidic medium, what we are confirming now is our electron. So since the electron are in opposite side, they are completely balanced. So what least to do now is to write this term very well in order for us to view it in a very appropriate manner. So you have 8 hydrogen ion plus 5 electron, which will now give me manganese 2 ion plus 4H2O. So since the electrons now are balanced, so we're going to cancel out the electrons since they're in the opposite side of the equation. And since this are in the opposite side of the equation, this is telling us that what we are doing is correct. If they're in the same side of the equation, which means they are very wrong. Here, the electron in the manganese is in the left hand side, while the electron in the ion is in the right hand side. Telling us that what we are doing is correct. So we're now going to go ahead and write this as a single equation. So writing this as a single equation, we have that Iron, we can start from iron, we can start from manganese. So let me decide to start from iron. So I have that iron 2 iron plus manganese O4 minus plus 8 hydrogen ion, which will now give me manganese 2 ion plus 5 ion plus 4H2. We are not going to write the electron because they will cancel each other. Balance the following redox reaction. Let's go ahead and balance the redox reaction. As you can see here, hydrogen is a spectator ion. So what are spectator ions? Spectator ions are elements or charge or compound which do not change before and after the chemical reaction. So let me tell you why I said hydrogen is a spectator ion. So we are not going to use this. We are going to just go straight and eliminate hydrogen, because if you balance hydrogen, as you can see there, we have hydrogen to water. So to balance this hydrogen plus, we have to add oxygen, and for us to add oxygen, I have to add 1 mole of oxygen, 1 mole of water in order to add oxygen to the left hand side of the equation. In a redox reaction, anything that is in the left hand side must be equal to anything that is in the right hand side. So here is H2O. So for this thing to be balanced, I have to add hydrogen plus. So you see, here and here is the same, so they will simply cancel out. So this is the reason why I said they are spectator ion, because they do not change before and after the reaction, and the oxidation number is the same. For here, the oxidation number of hydrogen is +1, and the oxidation number of hydrogen in water is +1, because if you're asked to find the oxidation number of hydrogen in water, recall that the oxidation number of hydrogen in water 2, and oxygen is -2 in a periodic table, which is equal to 0. So hydrogen, which is 2x, equal a minus crossing an equality sign will give us +2. So 2 divided by 2 will give us s is equal to what? +1. So as you can see now, we are going to eliminate hydrogen because it is a spectator ion. So I'm not going to use it while solving in this question. So let's go ahead and use the others. Let's start with beryllium. So I have my beryllium 3 minus, and beryllium is also in the right hand side of the equation, so I'll equate it to beryllium ion. Since the atom in beryllium is balanced, so I'll go ahead and balance the oxygen atom. So to balance the oxygen atom, 3 oxygen atom is here, so what I will just do is to add water to the right hand side. Recall that to balance oxidation number or to balance oxygen in a compound or during a redox reaction, you have to add how many moles of water required to balance the oxygen. Look at what I mean here. Since I have 3 oxygen here, I have to add 3 molecules of water. If that here was 2, or the oxygen here was 1, I will go ahead and add 1 molecule of water. But since the oxygen atom here is 3, so I'll add 3 molecules of water in order for me to balance it. So I now have my beryllium 3 minus, which will now further give me beryllium minus plus 3H2O. So I have 6 hydrogen ion, so I will come here and write 6 hydrogen plus. I have to balance the equation. The total number of atom here is the same with the total number of atom here, and the total number of oxygen here is equal to the total number of oxygen here. So what is remaining? The charge. So how many charge are here? So here we have -1 and +6. So I have -1 and +6, because 6 times plus will give us 6, and here I have -1. So to balance this charge, how many electron do I need to add in order for me to balance this? let's complete this then. I have plus here and I have minus 1. So to balance this, recall that electron is negative, so I'm not going to add it to the negative side, rather I'm going to add it to the positive side. So adding this to the positive side, which is 5, I'm going to add 6 electron in order for them to be minus 1. So if I should add 6 electron, so I'll have here minus 1, minus 1. So here now is now balanced because I have beryllium and I have beryllium, which is balanced. I have total number of hydrogen 6 and I have 6, which is balanced. I have oxygen to be 3 and I have oxygen to be 3, is now balanced, and I have equal charges, which is minus 1 and minus 1. So I'll now go ahead and add what I need. So what do I need now? Beryllium 3 minus plus 6 hydrogen plus 6 electron. This is my electron, and this will now give me beryllium minus 1 plus 3s2o. So this equation is now balanced. So let's go ahead and balance the iodide in this equation. So to balance the iodide in this equation, we're going to record that iodide minus 1 will give us iodide 2. So to balance this, I'll just go ahead and multiply by 2. So if I should multiply by 2 and I have 2 and I have 2, the atom is balanced but the charge is not balanced. So to balance the charge, I will go ahead and add electron. So from what I said, where are we going to add electron? So we are going to add electron to the place with positive side. Look at what I mean. Here is minus 2 and here is 0. So where are we going to add electron? So if I should decide to add 2 electron here in order to balance this, you see I'll have minus 4 electron and I will have 0. So the equation is not balanced. So to add electron, you are going to add electron to the positive side and not to the negative side. Or if there is 2 negative signs there, you're going to add electron to the one which is more positive. So here, what am I going to do? Since I have 0, so I'll go ahead and add 2 electron. So adding 2 electron, here will become minus 2 and here will become what? Minus 2. So this equation is now balanced. So I will now go ahead and add here to be what? Minus 2 electron. So these are the half equation. Since I have the 2 half equation, what I'm going to do is to just add it up now. And from here, which one undergoes oxidation and which one undergoes reduction? So from here, we can see that iodide moves from minus 1 to 0. Let's go back to our equation. In our equation, iodide moves from minus 1 to 0. So iodide undergoes oxidation. And from our equation, we have the oxidation number of beryllium here to be minus 1. And what is the oxidation number of beryllium here? So 3 times minus 2 crossing equality sign will give us a positive 6 minus 5. So here is plus 5 and here is what? Minus 1. So beryllium undergoes reduction. So what can we make from this deduction? We can make deduction that since iodide undergoes oxidation, therefore iodide is the reducing agent, and since beryllium undergoes reduction, therefore beryllium is the what? Oxidizing agent. So what is the characteristics of an oxidizing agent? Oxidizing agents, they are agents which is reduced during the chemical reaction or during redox reaction. Why reducing agent is the agent which is oxidized during redox reaction. So since we have these two things, we can go ahead and add it in both sides of the equation. But For us to do this, the electron here is not balanced. As you can see, I have -2 and I have -6. So what will I need to do in order to balance this? In order for me to balance this electron, I will multiply it by 3. So multiplying this equation by 3, since here is already 6, I don't need to multiply it by 3. What I'll just do is to multiply it by 1. So it will not change. Nothing here will change. But here it will change. And why are we multiplying it by 3? So both sides can have the same number of electrons. What is redox reaction? Because the redox reaction, total number of electron loss is equal to the total number of electron gain by electron transfer. Increase in oxidation number is an example of oxidation. So multiplying this term by 3, I now have 6 iodide ion, which will now give me 3 iodide plus 6 electron. Since they're the same and they are in opposite side, I will now go ahead and cancel out the electron. So cancelling out the electron, which is -6 and -6 electron. This cancelling out, I now have my equation. So I'll go ahead and write this equation. This 6 iodide will be at the left hand side together with this equation, while the 3 iodide will be at the right hand side together with this equation. So let us go ahead and write it. So I will now have barium plus 6 hydrogen ion plus my iodide ion, which is what? This 6 iodide ion, which will now give me barium -1 plus 3 hydrogen plus 3 iodide ion, which is from here. Since I have all these things now, so I'm going to check whether if my equation is balanced. So how am I going to check whether if my equation is balanced? To check whether if my equation is balanced is everything in the left hand side must be equal to everything in the right hand side. So barium, I have 1 and 1 is here. Oxygen, I have 3 and 3 times this is here. Hydrogen, I have 6 and 3 times 2 is here. Iodide, I have 6 and 3 times 2 is also here. So our atoms is balanced. So let's check whether our charge is balanced. So here the charge here in barium is -1. The charge in hydrogen ion is +6, and the charge in iodide ion is -6. So to the right hand side of the equation, the charge in barium is -1, the charge in water is 0, and while the charge in iodide is, so +6 -6 will now give me 0. So I have -1 and here I have -1. So therefore the equation is balanced since everything in the left hand side is equal to every substance in the right hand side, and our charge is balanced. So let's go ahead and practice more questions on this topic. So I have vanadium, I have this equation here. So they asked us to balance this equation. So to balance this equation, what do I need to do? So what I need to do is to write down the oxidation number. So from here, the oxidation number of vanadium is +3. The oxidation number of peroxide. So to check the oxidation number of peroxide, recall hydrogen is what we're looking for. So this is 2x plus 2 times -1 is what? -4, because oxygen, the periodic table is -2. So 2 times minus 2 is minus 4. So this is equals to 0. So 2s minus 4 crossing an equality sign will give us a positive 4. Therefore 2 divided by 2 will give us s is equals to plus 2. So the charge here is equals to plus 2. To balance this equation, first I will write this in the half cell reaction. So to balance this, what do I need to do? What I need to do exactly is to add oxygen to both to the left hand side. And since I have only one oxygen, I'm not going to add 2 molecules of water. What I'm going to add here is 1 molecule of water because I have only one oxygen in this equation. So adding 1 molecule of water, I'll now have vanadium is 3 plus 1 molecule of water, which is this, and this will now give us this. Is the equation balanced? No, because there is hydrogen ion here. So since there is hydrogen ion, I'm going to add hydrogen ion to the right hand side of the equation to balance the equation. So here I now have 3 plus water, which will now give us VO2 plus 2 hydrogen plus. Is the atom balance? I have vanadium, I have 2 hydrogen, I have 2 atom of hydrogen, I have 1 atom of oxygen, and I have 1 atom of oxygen. So the equation is balanced. So what I need to is to balance the charge. So to balance the charge, I have plus 2 and I have plus 2. Plus 2 from this and plus 2 from this, because 2 times plus 2 is plus 2. So here will not give me total of plus 4 charge. Here I have only plus 3. So what do I need now in order for me to balance this equation? In order for me to balance this equation, will I add electrons to the left hand side or to the right hand side, and how many electrons do I need? So since the difference in the charge of these two compounds is 1, so where will I add the electron? Will I add it to the left hand side, which is 3, or will I add it to the right hand side, which is 4? So I will add it to the right hand side, which is 4. So if you guess this correctly, which means you're understanding and you're following. So I'll add plus 1 electron to the left hand side of the equation, to the right hand side of the equation. So adding plus 1 electron, and I have plus 3 and plus 3. So since this is what I have, is the equation now balanced? Yes. So what I need to do is now to add the electron to the equation. So here will now become vanadium plus 3 plus H2O, which will now give me vanadium oxide plus 2 hydrogen plus 1 electron. So this equation is now balanced. What am I going to do for the hydrogen peroxide? So for the hydrogen peroxide, we have to write our hydrogen peroxide, which is this and this. What is the first thing I'm going to do? So the first thing we are expected to do in this kind of equation is you have 2 hydrogen here. So we're not going to consider the oxygen because we already know to balance oxygen, we're not going to multiply. We're going to add to the number of molecules of water depending on the number of atoms of oxygen. So, but for other atoms, what we're going to do is to just go ahead and multiply by the total number of atoms in the equation in order for us to balance it. So I have 2. I'll go ahead and multiply here by 2. So hydrogen atom is now balanced, and oxygen, to balance oxygen, I will now involve how many molecules of water will I involve since I have two atoms of oxygen. So the molecules of water I will involve is 2H2O. So since this is what I need for this equation, I'll go ahead and add 4 hydrogen ion to the left hand side. So here will now become this plus 4 hydrogen ion plus 2 hydrogen ion plus 2H2. If you observe something, notice that I added 4 hydrogen ion. Why? Because there is 4 here. 2 times 2 will give us 4. So this is what we need. So let us check our charge. Here I have plus 4 and here I have 2 plus. So what do I need to do? I'll go ahead and add 2 electrons here in order for this redox reaction to have plus 2 and plus 2. But I can also do something else. I can also decide to subtract 2 hydrogen ion from this equation, leaving us with only 2 hydrogen plus. And if I should add 2 electrons, I will still have the same 0, 0. So anyone you decide to do is your concern. But I'll prefer leaving the equation this way and adding 2 elements, 2 electrons to the left hand side of the equation. So since I have plus 4 and here I have plus 2, so which side are we going to add the electron? So we're going to add the electron to the left hand side. And how many electrons are we going to add? We are going to add plus 2 electrons for them to have plus 2 plus 2. Since we have this, we are now going to go ahead and do what is necessary. I prefer writing in blue. 0.2 plus 4 hydrogen and our electron, which is 2, which will now give me 2 hydrogen plus 2H2O. Since our equation is now balanced, but the number of electron is not balanced, so how are we going to balance the electron? So to balance the electron, I'm going to multiply vanadium, or the first equation, by 2. So I have 1 electron here and I have 2 electron here, so it's not balanced. So I'll multiply by 2. So multiplying this equation by 2, while here I'll multiply by 1 so that the equation will not change, because the electron will be the same. So if I should multiply this term by 2, the electron will be the same. And if the electron to be the same, is not a redox reaction. The total number of electron loss is equal to the total number of electron gain. So let's go ahead and do this. So multiplying this equation will now change to vanadium 3 plus 2, and here will become 2H2O, and here will become 2V plus, here will become 4 hydrogen plus, and here will become 2 electron. 2 multiply in vanadium give us 2. 2 multiply in water will give us 2 molecules of water, and 2 go here will give us 2 vanadium oxide, and 2 in hydrogen ion will give us 4. 2 times 2 is 4, and 2 in 1 electron will give us 2. So if I should multiply the second equation by 1, it will not change. So I now have 2O2 plus 4 hydrogen plus 2 electron, which will now give me 2 hydrogen plus 2H2O. So the electrons are balanced now, and they're in opposite side. So I'm going to go ahead and cancel out. This will cancel out this. I have 2 molecules of water. 2 molecules of water will cancel out 2 molecules of water. I have 4 and I have 4. 4 will cancel out 4. So let's go ahead and write the balanced equation for this reaction. So writing the balanced equation, we now have 2 barium plus 2, and I have peroxide there. Peroxide is this, so I will now bring it on H2O O2, and nothing else is remaining in the left hand side of the equation. So I'll go over to the right hand side of the equation. I have vanadium, which is this, and I put my vanadium oxide, which is plus 2, and I have my 2 hydrogen ion. So I'll go ahead and add my 2 hydrogen ion. So let's check whether this equation is balanced. To check whether this equation is balanced, the total number of atom and electron in the left hand side must be equal to the total number of atom and electron in the right hand side. So I have 2 as vanadium, and I also have 2 as vanadium, and I have hydrogen to be 2, and I also have hydrogen to be 2. So vanadium and hydrogen is balanced. I have my oxygen to be 2, and I also have my oxygen to be 2. So it is now balanced. What about our charge? So my charge, I have 3 plus in the left hand side multiplied by 2, which will now give us 2 times 3 will give us 6 plus. Why in the right hand side, I have 2 multiplying by 2. 2 will multiply this 2, which will now give me plus 4, and this 2 multiply this 1, which will now give me plus 2. So I have plus 6 and I have plus 6. Therefore, this equation is balanced. Let's solve more questions. Given that the following reaction, what are we going to do? So from what you have learned, feel free to pause the video and try doing this one yourself. What are we going to do? So what we are going to do first is to observe or check if there is any spectator ion, or let's go ahead and write the oxidation number for each element there. So writing the oxidation number for each compound here, we're going to, for sulfur, we are calculating the oxidation number of sulfur. So sulfur here, I have 2 as oxygen multiplying by 2, which is equal to 0. So I have plus 2. So I now have minus 4, because oxygen is minus, which will now give me 0. So here I now have plus 4. So the oxidation number of sulfur here is plus 4. For water, equals to 0. So we are calculating the oxidation number of hydrogen. So the hydrogen will be S. So this is 2 multiplying by X, because there is 2 in the subscript, plus oxygen is minus 2 in the periodic table. Oxygen has a charge of minus 2. So here will become 2S minus 2. Crossing an equality sign will give us plus 2. So I'll divide these two in order to make S the series of formula. So I now have S to be equals to plus 1. So the oxidation number of water here is plus 1. So what is the oxidation number of beryllium here? So the oxidation number of beryllium is equals to 0, since there is no atom here. If I go ahead and make S, multiplying this by 2, I have also 0. So divide this by 2, S is also equals to 0. So beryllium here is 0. So hydrogen is plus, so it is there already. So the oxidation number of hydrogen is 1. And for sulfur, let me create a space. So for this, I have equals to 0. So we are calculating the oxidation number of sulfur in that compound. So I will now make sulfur to be X, plus oxygen is minus 2 multiplying by 4 is equals to 0. So X is now plus 4 times minus 2 will give us minus 8, which is equals to 0. But I have a charge, so they are not equals to 0 because there is a charge here on top of this. So this charge is now equals to minus 2, equals to minus 2, and equals to minus 2. So minus 8 crossing an equality sign equals minus 2 plus 8. So here I now have minus 2 plus 8 will now give me plus 6. So the oxidation number of sulfur here is plus 6. So the oxidation number of beryllium in the last one is equals to what? Minus 1. Is equals to the charge, which is equals to minus 1. So from here, which one is oxidation and which one is reduction? And which one is undergoing reduction and which one is undergoing oxidation? And which one is the reducing agent and which one is the oxidizing agent? So if you observe, sulfur moves from plus 4 to plus 6. So what is the characteristics of a reducing agent? The characteristic of a reducing agent is the one which is what? Oxidized. So sulfur undergoes oxidation and therefore sulfur is the what? The reducing agent. And in water we have plus 1 and we also have plus 1. So what is spectator ion? Spectator ion are compounds, elements or atoms who do not change before and after the reaction. So water is spectator ion and hydrogen is also a spectator ion. So I'm going to go straight and eliminate it. We're not going to add it in the equation because if you add it, you're going to end up having hydrogen plus water and hydrogen plus water, which they will later cancel out. So we're going to leave it like that. So what of beryllium here? Beryllium here has 0 in the left hand side and it is minus 1 in the right hand side. So what can you say or what deduction can you make here? So beryllium undergoes reduction. So what is the characteristics of an oxidizing agent? Oxidizing agent is the one which is what? Reduced. So beryllium is the oxidizing agent and beryllium is the one that undergoes reduction. So let's go ahead and balance this equation. I'm emphasizing on these oxidizing and reducing agents because in some question they'll ask you which one is the oxidizing and which one is the reducing agent. So let's go ahead and balance this equation. You can start from oxidation, you can start from reduction. So all lies or in your choice. So I have here to be beryllium and I have here to be beryllium minus 1. So what will I do? Think of what I will do. So what I will do first is I'm not going to add water or any other thing to this equation because it is not oxygen. So what I'm going to do is to add water. What I'm going to do is to multiply this equation by 2. So multiplying this equation by 2, I will now have 2. Not really that I'll multiply the equation by 2, but I'll multiply the right hand side by 2 so that I will now have 2. So from here the equation is balanced but the charge is not balanced. So what will I do to balance the charge? So what I need to do to balance the charge is, since I have here to be minus 2 and since I have here to be 0, so which place or which side should I add electron? This is very, very, very important. So try thinking of it. So what I'm going to do here is, and I'm going to add electron. So I'm going to add electron to the left hand side. Why? Because 0 is more positive than what? Minus 2. And 0 is greater than minus 2. So if I should decide to add minus 2 here, minus 2 electron, you see here will become minus 4 and here will become 0. So the equation is not still balanced. So what I'm going to do is to add 2 electron to the left hand side and not to the right hand side. So adding 2 electron, I'll now have minus 2, and I'll now have minus 2, which is minus 2 and what? Minus 2. So the equation is now about to balance. So I will go ahead and balance it. So beryllium will now be this plus 2 electron, which will now give me 2 beryllium minus 1 plus nothing else. Since I have my equation to be balanced for the first, so let's go ahead and balance for sulfur in the equation. So to balance for sulfur, how you do this? And mind you that we have been balancing in acidic medium. If they ask you to balance in basic medium, what are you going to do? But let's first balance this first. So I have oxygen, 2 atoms of oxygen on the left hand side, and I have 4 atoms of oxygen in the right hand side. And sulfur, I have 1 and I have 1 in both sides of the equation. So for sulfur is balanced, but oxygen is not balanced. So what am I going to do? I'm going to involve how many molecules of water? So since I need, how many molecules of water will I going to add? So I'm going to add 2 molecules of water. Why? Because 4 oxygen is here and 2 oxygen is here. So how many oxygen is required? Not 4. We need extra 2 and not 4. So note that. And where are we going to add it? Are we going to add it to the right hand side, or are you going to add it to the left hand side? So we are going to add this equation to the what? Left hand side, not the right hand side, because the right hand side is greater in oxygen than to the left hand side. The left hand side has or is deficient in oxygen when compared to the right hand side. So I'm going to go ahead and add oxygen. So adding oxygen to the left hand side, I will now have this as my equation. So I will now have adding 2 molecules of water is now balanced, because I have sulfur here, 4 hydrogen, but hydrogen is not here. So I'm going to go ahead and add what? How many atoms of hydrogen? 4. I hope you are understanding what I'm doing. Now, what are we going to do next? Since our atoms are now balanced, I'm going to go ahead and check for our charge. So my charge, I have my charge to be 0, and I have my charge to be minus 2 plus 4, and I have my charge to be plus 2. So what am I going to do? Will I add electron to 0, or will I add electron to plus 2? So 0 and plus 2, which one is more positive? Plus 2 is more positive. So if I should decide to add minus 2 electron to the left hand side, you see here is minus 2 and here is plus 2. So the equation is not too balanced. What I'm going to do is to add 2 electron here. So adding 2 electron here, and I have 0 and 0. So therefore the equation is about to balance. So I'm going to go ahead and add the 2 electron. So adding the 2 electron, I'll now have sulfur 2 plus 2 hydrogen plus 2 molecules of water, which will now give me sulfur 4 minus 2 plus 4 hydrogen plus and my 2 electron. So you have to notice something. Since we have been balancing this equation, electrons are not at the same side. Electrons are always at positive at opposite side. So if you are balancing any redox reaction and the electrons are in the same side, just note there is error somewhere. So go back and start balancing from the beginning. So since I have two electron and two electron, so we don't need to multiply any equation. We're going to just go ahead and add to both sides of the equation, which this is now beryllium minus 1. So I'm going to add it to both sides of the equation, giving me S2 plus 2 molecules of water plus beryllium. Electron we cancel out. So I now have sulfur 2 minus plus 4 hydrogen plus 2 beryllium minus 1. So let's go ahead and check whether our equation is balanced. To check whether our equation is balanced, everything in the left hand side must be equal to everything in the what? Right hand side. So here I have my sulfur to be 1 and sulfur here is 1. I have my beryllium to be 2 and beryllium here is 2. What of my hydrogen? I have my hydrogen to be 4 because 2 times 2 will give me 4 and here is 4. What about the oxygen? So oxygen, definitely I have 4 oxygen at the right hand side. What of the left hand side? So I have 2 times 2. So I have 2 oxygen plus another 2 oxygen from the sulfur. So making it total number of 4 oxygen. So our equation is balanced. So this is when you are asked to balance this equation. Let me say you are asked to balance this equation in acidic medium. So, and mind you that you have been balancing in acidic medium. So if you are asked to balance in basic medium, what are you going to do? So to balance this equation in basic medium is just the same process, but the only difference is after balancing in acidic medium, you go ahead and add hydroxide ion. This is hydroxide ion based on the number of hydrogen present in the equation. For instance, let's go back to our former equation. Here we have 2 hydrogen. So if you are asked to balance this in basic medium, you go ahead and add 2 hydroxide ion to both hand side of the equation because there is presence of what? 2 hydrogen ion. So coming back here, I have 4 hydrogen ion. So how many hydroxide ion do I need to add? So I need to add 4 hydroxide ion to both hand side of the equation since I have 4 hydrogen ion. So why am I going to add 4 hydroxide ion? They say it is basic. So the presence of hydroxide ion and presence of water will tell us that this is a basic medium. So these two things will tell us that, hey, what we're doing is basic. And when you see hydrogen plus in an equation, it tell you that that equation is balanced in acidic medium. Let's go ahead and balance this equation. So adding hydroxide ion to both sides of the equation. Let me emphasize on something. Hydrogen plus hydroxide ion will give us what? Water. Why? How? I have one here, I have one here, and which is total of what? 2, and hydrogen here is 2. So the equation is balanced, and I have oxygen 1 and I have oxygen here. So the equation is balanced. And since this is opposite charge, they will just cancel out. They have the same charge and opposite charge, so they just cancel out and add up. So let's go ahead and balance this equation. So introducing 4 hydroxide ion to both sides of the equation. So our equation will look something like this. plus hydroxide ion. How many hydroxide ion? 4 hydroxide ion, not 1. Which will now give me sulfur 2 minus plus 4 hydrogen ion plus 4 hydroxide ion plus 2 beryllium ion. So since I have all this, what next will happen? Sulfur 2 plus 2 molecules of water plus beryllium plus 4 hydroxide ion will now form S4 minus 2. So recognize the presence of what? Hydrogen and hydroxide ion. So recall that I said since it is hydrogen and hydroxide ion, both of them will add up to what? Form water. And let me emphasize on something. If there were 2 plus 2 hydroxide ion, this will definitely give us 2 molecules of water, because I have total number of what? 4, and total number of 4 hydrogen ion is here, and I have 2 and total number of 2 oxygen ion is here. So to do this kind of thing, just bring out the hydrogen ion plus hydroxide ion, which will now give us water. So if they were 2, just go ahead and add 2. But if they were something like, let me say 10 or 20, look at what we are going to do. The only thing we are going to do here is, let me say 10 hydrogen ion is reacting with 10 hydroxide ion. So this will now give us what? 10 total number of water. So how did I do this? So you're going to just go ahead and just write hydrogen plus hydroxide ion will now give us what? Water. So due to 10 was here and 10 was here, just bring out and just write 10 once. If it was 20, just go ahead and write 20. So this is how it works. So since I have 4 reacting with 4 hydroxide ion, so I now have water. So what am I going to do? I'll just add 4. So let's check whether it's balanced. So hydrogen here is 4, hydrogen here is 4, total number of hydrogen here is 8. So 4 times 2 is what? 8, and oxygen is 4. 4 times oxygen is now what? 4. So it is now balanced. I'm going to just go ahead and write 4 molecules of water plus 2 beryllium ion. So notice that this equation is balanced, but there is one last problem. We have water here and we also have water here. So water cannot be at both sides hand of the equation. So what I'm going to do is what? To eliminate, to minus or to subtract. So what am I going to do? I'm going to subtract 2 molecules of water here and subtract 2 molecules of water to both sides of the equation, so that molecule of water will be what? 2 molecules of water. You cannot subtract more than what you need. Look at what I mean. Since 2 here and 4 is here, you cannot come and subtract 8. That's 8 or 4. What's in this kind of equation? What you are going to do is look at both hand side of the equation and check the one with what? Lesser water. If there were 8 water here and water here was 15, what am I going to do? I'm not going to subtract 15 nor 18 nor 8 nor 10. So what I'm going to do is I'm going to check the one with lesser water. So within these two equations, which one has more lesser water? So it is 8. So what I'm going to do, I'm going to just come and put minus 8 molecules of water. I have to subtract and I'll do the same to the right hand side of the equation, which is minus 8 molecules of water, so that this will cancel us, leaving us 0 molecules of water, and leaving us with 8 minus 15 will give us 7 molecules of water. So this is how this works too. So I'm not going to come and subtract 4. So what I'm going to subtract is minus 2 molecules of water. So subtracting minus 2 molecules of water, I will now have 2 plus beryllium plus 4 hydroxide ion. Notice that this is out because I've subtracted it, which will now give us SO4 minus 2 plus 2 minus 4. So in subtracting water, you're not going to think much. Just for instance, if you have 3 molecules of water and you have to subtract what? 2. So what you're going to do is just bring out your molecule of water, which is this, and do your normal mathematical calculation, which is 3 minus 2, which is what? 1. So what will be left there is 1. If 18 molecules of water was here, so and you asked to subtract with, let me say 8 molecules of water. So what you're going to do is just write some molecules of water, which is this, and do your normal mathematical calculation, which is 18 minus 8, which is now 10, which is 10 molecules of water. So from here, what next are we going to do? So 4 minus 2 will now give me 2 molecules of water. So this will now give me 2 beryllium minus 2. So our equation is now balanced, but note that this equation is balanced based on basic medium. This, you're going to do all this when you are asked to balance in basic medium, but if you're asked to balance only in acidic medium, your endpoint should be here. You're not going to introduce this hydroxide ion. Your endpoint should be where we are not going to introduce our hydroxide ion, but here we have already introduced our hydroxide ion, so here's not our endpoint. But if you are asked to balance in basic or in both acidic and basic medium, go ahead and balance in acidic medium first. So after the equation is balanced in acidic medium first, you now go ahead and balance in basic medium. So let's check whether our equation is correct. I have one here, I have one here, I have my oxygen to be, I have total number of oxygen here 4 plus 2, which is what? 6 oxygen, and I have 4 plus what? 2, which is what? 6 oxygen. So therefore oxygen is balanced. So here I have beryllium to be 2 and I have beryllium to be 2. My hydrogen, I have my hydrogens to be 4 and I have my hydrogen to be 4. So let's talk about our charge. So my charge here is minus 4 and my charge here is minus 2, and 2 times minus 1 is minus 2. So I have minus 4 and minus 4. So the equation is balanced. Let's solve more problems based on this topic. Redox reaction is a very essential aspect in chemistry that in any exam you are writing, probability of meeting redox reaction is about 70%. If you are writing any chemistry exam, you must see redox reaction. It's a compulsory something. You must see it. So I have this chromium heptaoxo and I have ion and I have chromium there 3 plus and I have ion 3 plus. So let's first write the oxidation number. So oxidation number of ion here is plus 2, oxidation number of chromium here is plus 3, oxidation number of ion here is plus 3. So what is the oxidation number of heptaoxo there? So the oxidation number here is equals to minus 2. We are asked to calculate the oxidation number of chromium here. So chromium will now become S and it has a coefficient of 2. So I'm going to multiply it by 2S plus oxygen is minus 2 and 7 is multiplying oxygen. because of this. So this is raised to the power minus 2. So I'll now equate it towards minus 2. If there were nothing there, or if nothing was there, it should have been 0. But since minus 2 was there, it is minus 2. So 2x 7 multiplied by minus 2 will give us minus 14, which will give us minus 2. So plus times minus will now give us minus. So this is minus 14, which is equals to minus 2. So 2s minus 14 crossing an equality sign will give us positive. So it will now become 14 minus 2. So basically 14 minus 2 is 12. So I'll divide the equation by 2 in order to make s the result formula. So s will now become plus 6. So the oxidation number here is what? Plus 6. So now we know the oxidation number of the compounds and elements present in this redox reaction. So my questions is, first, feel free to pause the video and try doing this one yourself. Balance the equation in both acidic and basic medium. Secondly, find the one that undergoes oxidation. Thirdly, find the one that undergoes reduction. Fourth, which one is the oxidizing agent? Fifth, and which one is the reducing agent? So I asked 5 questions, so you're expected to answer this question if you are truly following in this course. So first question is balance the equation, which we are going to do later. So which one undergoes oxidation? As you see with your eye, ion move from +2 to +3. So this one, ion undergoes oxidation. So chromium move from +2 to +3. So chromium undergoes reduction. So therefore, which one is the oxidizing and which one is the reducing reagents? So the oxidizing reagents is what? Chromium, because chromium is reduced. Characteristics of oxidizing agents. Oxidizing agent is the agent which is what? Reduced. So iron is what? The reducing agent, because it's the one that is what? Oxidized. Characteristics of a reducing agent. A reducing agent is the agent which is oxidized during redox reaction. So the 4 questions has been answered, remaining 1, which is balance the equation in both acidic and alkaline medium. So let's go ahead and balance them. So I'll write my chromium to be 7 minus 2 and +3. So what is the first thing I need to do? Will I first and add molecule of water, or will I first unbalance chromium? So when adding molecules of water, if your atom present have not been balanced, so adding molecules of water first is wrong. You're going to first unbalance the atom before considering the oxygen. The oxygen in redox reaction, the oxygen should be the last thing that should be in your mind. So to balance this, I'm going to multiply the right hand side by 2. So I will now have something that looks like this: 2 chromium plus 3. So what next? I have how many molecules of oxygen and how many molecules of water will I need to add? So I'm going to add 7 molecules of water. Why? Because there is 7 here. So adding 7 molecules of water, I have to involve my hydrogen. So adding hydrogen, I will now have 7 molecules. I will now have this plus 7 times 2 will now give us 14 hydrogen ion, which will now give me 2 chromium plus 7 molecules of water. Let me rewrite that equation very well. So their place is 7. they will not give me 7 molecules of water. Why did I add 14? Because 7 times 2 is what? 14. So let's check whether this equation is balanced. I have 2 chromium here, I have 2 chromium. Chromium is balanced. I have 14 hydrogen here, I have 14 hydrogen here. Hydrogen is balanced. And what next? I have 7 molecules of water, 7 molecules of oxygen, and I have 7 molecules of oxygen. So the equation is now balanced. So what of the charge? What happens to the charge? So I have -2 and 14. So I have a total charge of plus 14 minus 2 will basically give us 12. And I have a total charge of 2 times 3 because this is raised to the power 3. 2 times 3 will now give us what? Plus 6. So what am I going to do now? Answer this question. Will I add electron to the right hand side of the equation or to the left hand side of the equation? So I'll add electron to the what? Left hand side of the equation. And how many electron will I add in order to balance the equation? So I need to add 6 so that the total number of electron will be the same. So here will not give me plus 6 and here will not give me plus 6. So let us go ahead and write this equation in a very suitable manner. So here I will now have something like looks like this, plus 14 hydrogen plus I added 6 electron, and this will now give me 2 chromium plus 7 molecules of water. So this one is balanced. What of my ion? For the ion, I have this. So ion, how many electrons do I need to add? First is the atom balance. So I have 1 molecule of atom here and I have 1 molecule of atom here. So the atom is balanced. So what about the charge? Where will I need to add electron? Will I add electron to the left hand side or to the right hand side? So I'm going to add electron to the what? Right hand side. Give me total of what? +2 and what? +2. If that I decided to add electron to the left hand side, so I'll be having something like this, +2 adding +1 electron. So this will now give me +1 and what? +3. You see, it is not balanced. So the only way is to add 1 electron to the what? Right hand side. And since I've added electron to the right hand side, you know, when solving equation, something will be telling you whether you are right or correct. So how will you know if our equation is right or correct? In solving redox reaction or in balancing redox reaction, the ion, the electron must be at opposite side. So if you are solving electron and it is in the same side of the equation, is wrong. As you can see here is what? At the right hand side, and here electron is at the what? Left hand side, telling us that what we are doing is absolutely correct. So since that I have this equation now, I'm going to go ahead and add it in the equation. But adding it, you see that the total number of electrons is not the same. So what I'm going to do is just multiply here by 1 and multiply here by 6 to balance the total number of what? Electron. So ion multiplied by 6 will now give me 6 ion, which will now give me 6 3 ion plus 6 electron. So I now have the same ion. Therefore, the equation is now balanced now. So what next am I going to do? So I'm going to cancel out the electron since they're in opposite side. So cancelling out the electron, I now have the remaining. and I'm now going to add it. So adding the two half reaction, I'll now have something that looks like this, plus 6 ion, which will now give me 2 chromium plus 7 molecules of water and 6 ion. And mind you that I can decide to start from ion. I can also decide to start from chromium. So everything lies on your choice. So let's check whether this equation is balanced. And if the equation is balanced, this is an acidic medium. Why? Because there is presence of what? Hydrogen ion. This is an acidic medium. But if there is presence of hydroxide ion, which means we have balanced it in what? Basic medium. So let's check whether our equation is balanced. I have 2 chromium, I have 2 chromium. Chromium is balanced. I have 14 hydrogen. I have 7 times 2, which is 14. So the equation is balanced. I have 6 ion and I have 6 ion. Therefore, ion is balanced. I have 7 molecules of oxygen and I have 7 molecules of oxygen. So therefore, the equation is balanced. So what happens to our charge? Let's check whether our charge is balanced. So I have total number of what? -2 plus 14 plus what? 12, which will now give me 2 times 3 will give me 6 plus 6 times 3 will give me 18. So let me make some space. So -2 plus 14 will give me 12 plus 12, which will give me 6 plus 18 is 24. And 12 plus 4 is what? 12 plus 12 is 24. So I have total number of charge of plus 24 and plus 24. So therefore, the equation is balanced. That undergoes reduction, and we can also identify the one that undergoes oxidation. And I will also believe now that you can also balance in basic and acidic medium. So you are expected now to just any equation I bring out now, you pause the video, balance, and after balancing, use my own to cross check what you have already done. So I'll add 4 molecules of water here. Also the presence of 4 molecules of water here. So since I have this, I'll go ahead and add 8 hydrogen plus, which will give me manganese 2 plus 4 molecules of water. So I have this. So the question is, what is my charge? How will I identify my charge? My charge here, how to balance my charges? My charge here is -1, here is 8, here is 2. So therefore, the left hand side has a charge of what? 7, and the right hand side has a charge of what? 2. So how many electrons am I going to introduce? 5, 7 and 2. So I'm going to introduce 5 electrons in order for me to balance it. So I'll have something like this. 5 electrons. Why 5 electrons? So let's add all of them and check what we're going to get. So -1 plus this will give me total number of what? 7, and 7 minus 5 will give me 2, and here is 2. So the equation is balanced. So I'm going to now go ahead and combine the equation. But before combining the equation, we have to balance the electron. So So if you observe, this equation is now balanced, but there is error. In redox reaction, there will be nothing like gaining and gaining. One will be gaining and one will be losing. So here, both of them were gaining. So what we did is what? Wrong. It's definitely wrong. I purposely did this to know people that will detect the error and to know people that will just follow ahead. So this first one I did was wrong because I have 4 molecules of oxygen and I have 4. So why did I go ahead and introduce 4 again? So this is error you should consider. These are something that can make you fail exam. So open your eye, shine your eye, and be careful and practice a lot of questions under this topic to avoid making mistake like this in exam. So what am I going to do now? I'm going to clean it now and solve for the real one or solve for the main one. So let me shift this equation. So let's go ahead and solve the first one again. So I'll now have something like this. Which will give me 2. So immediately, since 2 is here, so I now add 2. So this is where the error started from. I went and add 4 again. So avoid that mistake when you are solving exam problems. Because this kind of question is question you're gonna meet in your exam. For those preparing something like JAMB, 100 level exam, JUPEP exam, and WAEC, NECO, you can see questions like this, and they have to trick you in order for you to fail it. Since I have this, my carbon is now balanced. So on the process of balancing my carbon, oxygen was also what? Balanced. But in balancing oxygen, you're not going to multiply it by 2. But since we wanted to balance our carbon, so during the process, oxygen was balanced. So we are not going to leave it like that. We are going to leave it like that. We are not going to introduce our water again. So let's write 2 hydrogen plus. Why? Because of presence of what? 2. So having 2 hydrogen plus, I'm going to add 2 electron here. So that here will become 0 and here will become 0. So now I have this equation. I have 2 and I have 5. What am I going to do? I think this one is a bit you have to be careful in this one than the other one we have been doing. So since we have this, I have 5 and I have 2, telling us that what we did was what? Correct, because I have, for the first one, the electron is in the right hand side, and for the second one, the electron is what? In the left hand side. So I'll go ahead and multiply here. What am I going to do? Think of what am I going to do first. So feel free to pause the video and try doing this one by yourself. So if you get it, fine. If you fail it, let's go ahead. So what I'm going to do now is I'm going to multiply here by 5 and I'm going to multiply here by what? 2. Why? If I should multiply here by 5, I'll have 10, and if I should multiply here by 2, I'll have 10. So the electron are not the same, because in redox reaction, total electron loss must be equal to the total electron what? Gain. You cannot lose 2 electrons and gain 5 electrons. It's not possible. What you lost is also what you are going to what? Gain. So This is 2 and this is 5. So I'll multiply here by 5 and multiply here by 2 in order to convert the electron toward 10 so that they can cancel out. So on the process of doing this, I will now have Hc2 5 because it's multiplying by 5, O4 plus 5 multiplied by 2 will give me 10 carbon 2 plus 5 times this will give me 10 hydrogen plus 10 electron. So 2 multiplied by manganese, I'll be having I think I'll be having 2 manganese 4 minus plus 16 hydrogen plus 2 multiplied by 5 will give me 10 electron. So we have arrived at what we need, 10 and 10, which we now equate it to 2 times this is now give me manganese 2 plus 2 times this will now give me 8 water. So since I have this, what am I going to do next? So I'll go ahead and cancel out the electron. So cancelling out, I'll now add all the equation. So adding all the equation, I'll now have 5C2O4 plus 2 manganese O4 minus plus 16 hydrogen plus, which will now give us 10 carbon 4 oxide plus 10 hydrogen plus 2 manganese 2 plus 8 molecules of water. So you have to observe something now. In this equation, I have 16 hydrogen, I have 10. They are in opposite side, they are not in the same side. If they were in the same side, what we did was wrong. They must be in opposite side. So now we know this, we have to now cancel out hydrogen. So hydrogen here is 16 and hydrogen and the other one is what, 10. So we have to do something. So in order to cancel out hydrogen, you're not going to subtract 13 nor any stupid number or something else or any number. What you're going to do is to check the smallest one. So which one is the smaller? The one that is very small here is 10. So what you're going to do is what, subtract 10 to both sides of the equation. So subtracting 10, I will now have 5H2C2O4 plus 2 manganese plus, if you subtract 10 from 16, you're going to be having 6, which will now give us 10 carbon 4 plus, subtracting 10 from 10 will give us 0. So there will now be 0. 2 manganese 2 plus what? H2O. So since we now have this, since we have arrived at this equation is now what? Balancing acidic medium. If you check it, you see that I have 10 hydrogen, I have 10 carbon, I have 5 times 2, which is 10. I have 2 times 4, which is 8, and 5 times 4, which is 20, plus 8, which is what? 28. And here I have 10 times 2, which is 20, and 8 times 2, which is what? 8 times 0, 8 times 1, which is what? 8. 8 plus what? 20, which is what? 28, which is I have 28, 28 oxygen. So our equation is balanced. So if you're asked to balance in acidic medium, this is what you're going to do. But in basic medium, you're going to go ahead and add our hydroxide ion based on what? Presence of what? Number of what? Hydrogen ions. So I'm going to add 6 hydroxide ions since I have 6 hydrogen ions. So here now become 10 plus 2 manganese 2 plus 8 H2O plus 6 hydroxide ion. So I will now have 5C2O plus 2 manganese plus 6 reacting with 6 will give us 12. Recall what I have said. 12 molecules of water, which will now give us plus 8 molecules of water plus 6 hydroxide ion. So I have 8 here, I have 12 molecules of water. So what I'm going to do is to subtract 8 molecules of water from the equation. So subtracting 8, I now have something that looks like this. So 12 minus 8 will give us 4. So this will now be equals to 10 carbon plus 2 manganese 2 plus 8 H2O plus 6 hydroxide ion. So let's check our charge. Our charge will be what? I have at my left hand side 2 times minus 1 will give us minus 2, and I have 2 times this, which will give me plus 4, plus what? 6 times minus 1 will give you minus 6, which is minus 2 and minus 2. So our equation is balanced. Let's start from this one. Let's balance this one. So balancing this one, I have this. So nitrogen here is balanced. How many molecules of water do we need? 1. So if you add 2 molecules of water, we are going to fill this question. So what you are going to add is what? 1. Or if you add 3 molecules of water, you still end up filling this question. So what you are expected to add is what? 1, because 2 have already subtracted 3, remaining what? 1. So we're going to go ahead and what? Write 1. So is this equation now balanced? Nope. So I have to have more process. So this is what we have. So I'm going to add 1 electron. Is the atom balance? 1 here, 1 here, 3, 3, and 2 hydrogen and 2 hydrogen. So the atom is balanced. So what do we need now is to balance the charge. So balancing the charge, I'll just add 1 electron here. So both can be what? 0, 0. So charge here is 0, and minus 2 plus 2 is what? 0. So let's balance for iodide. So in iodide, I have something like this waiting for me. I'll go ahead and add 3 molecules of water, which will now give me iodide minus, and I have 6 hydrogen. So let's check whether our atom is balanced. 2 here, 1 here. So what we did is wrong. If you go ahead and do this equation like this, you are going to fail. So what we are going to do is to multiply this equation by 2. So multiplying by 2, I'll now have iodide 3 and this. So I will now have to add oxygen, not more 3, rather 6. So adding oxygen, which is 6 molecules of water, which will give me 2 iodide plus 12 hydrogen ion. So let's check whether our equation is balanced. I have 6, and I have 12 hydrogen ion, and I have 12 hydrogen ion. So what happens to the charge? 2 times minus 2 gives us 10. So I'm going to add 10 electron here. So I will now have C6H2O, which will now give me 10 iodide plus 12 plus what? 10 electron. Allow for me to balance this. So since I have these two things, let me make a space. Why did I? Let me make a space. So since I have these two things, the electron is not balanced. So for the nitrogen, I will multiply nitrogen by 10 in order for me to balance the electron so that they can be the same. And for iodide, I'll multiply it by 1 since it has 10 electrons greater than the nitrogen. So I have this. Since I have this now, multiplying by 10, I'll have plus 10 times this will give me 20 hydrogen plus 10 times this will give me 10 electron plus 10 times this will give me 10 H2 plus 10 times this will give me 10 H2O. So 1 times iodide. So nothing in the second one will change. So I'm going to just copy and paste it the way it was. So they're in opposites, or they are not in the same equation. So they are in opposites. So I'm going to just go ahead and cancel out, giving me 10 electron plus 20 hydrogen plus hydrogen plus iodide 2 plus C6H2O, which will now give me 10 NO2 plus 10 H2O plus 2 iodide plus 12 hydrogen plus. So if you observe, we have 10 water here, we have 6 water here. So I'm going to eliminate the water. So eliminating the water, I'll now have something like 10 3 minus plus 20 hydrogen plus iodide 2. So I'll subtract 6. The 6 water we cancel, and I'll now have 2 iodide minus plus 12 hydrogen plus 10 NO2 plus, so 6 out of 10. 10 minus 6 molecules of water now give me 4 molecules of water. So let's go ahead and balance this equation in basic medium, because this is the equation in acidic medium. So to balance this equation in basic medium, I have 12 and I have 20. So what am I going to do? I'm going to subtract this equation by 12 in order to remove this equation, and also balance the equation in acidic medium for it to be completely balanced. So 12 minus 20 will give me 8 hydrogen plus iodide, which will now give me 2 iodide minus plus, the hydrogen is out, 10 NO2 plus 4S2O. Since I have this in acidic medium, so let's balance in basic medium. So to balance in basic medium, I'll just go straight and add its hydroxide ion. I hope you know how all this thing is getting, or how I'm doing all this thing. If you are not understanding it, go back and calm down and rewatch the video for better understanding. So hydrogen and water will now react. I will now have this plus 8 plus will now give me 8 water plus iodide, which will now give me 2 iodide plus 10 NO2 plus 4H2O. Plus my 8 hydroxide ion. I have 4 molecules of water and I have 8, so I'll go straight to the point and subtract. So subtracting this, we are now going to have this 4 in 8 will now give me 8 minus 4 will now give me 4 H2O plus iodide, which will give me 2 iodide plus 10 NO2 plus 4 we got, because I'm going to minus 4 give me 0 plus what? 8 hydroxide ion. So let's check whether our charge is balanced. So I have minus 2 minus 8, which is equals to minus 10. So here will become minus 10 and here will become minus 10. So this equation is balanced. So let's continue. Let's do this. I have hydrogen bromide. I have bromide 2. So the equation is not balanced. I'll multiply this by 2, giving me 2 hydrogen bromide, which will now give me bromide 2. But I have 2 hydrogen, so I'll now add 2 hydrogen plus. So is the equation balanced? I have 2 hydrogen, I have 2 hydrogen, I have 2 bromide, I have 2 bromide. So how many electrons do I need? So I need 2 electrons. So I have 2 bromine. So the equation is now balanced. So what happens to sulfur? Let me create space. 2 hydrogen bromide, which will give me 2 bromide plus 2 hydrogen plus 2 electron. So I'm free to clean this one out. Now I have this. What else? I have 2 oxygen. I have 2 oxygen. So I'll go ahead and add 2 molecules of water. Is the equation balanced? Let's check. I have 4 hydrogen, I have 4 hydrogen, I have sulfur 1, I have sulfur, I have oxygen 4, and I have oxygen 2 and 2, which is 4. So the equation is balanced. So what happens to our charge? So I'm going to add minus 2 electron here. So here will become minus 2, and here will become what? Minus 2. And if you notice, the electron here is minus 2. So the equation is now balanced. So I'm going to add 2 electron here. Adding 2 electron here, here will be minus 2 plus 4, give me 0. Here will give me 0. And I have 2 electron here, and I have 2 electron here. And they are in opposite side of the equation. So I'll go straight and cancel out. So since I'm not cancelling out, I now have what's remaining. So what I have remaining will now be sulfur 2 minus plus 4 hydrogen plus 2 hydrogen bromide, which will now give me S2O plus bromine plus 2 hydrogen ion. Let's check whether our equation is balanced. So checking whether our equation is balanced, we have oxygen 4 and I have oxygen 2 here. So I didn't write this plus 2 water. So writing it now. I'll now have this. So I have oxygen here 4. I have oxygen 2 times 1, 2 plus 2, 4. I have hydrogen plus another hydrogen 6. I have 4 plus 2, 6. I have barium 2, I have barium 2. So the equation is balanced. And our charge is balanced. Minus 2 plus 4 will give me plus 2 and plus 2. So our charge is now what? Balanced. So what next do we need to do? So we can go ahead and balance the equation in acidic medium. I'll add 4 hydroxide ion due to the presence of 4 oxygen, 4 hydrogen, not oxygen, plus 2 hydrogen plus 2 molecules of water plus 4 hydroxide ion. So these two will react, giving us S4 minus 2 plus 4 molecules of water plus 2 hydrogen bromide plus SO2 plus bromine plus 2 hydrogen plus 2 molecules of water plus 4 hydroxide ion. So since I have this, I have 2 molecules and I have 4 molecules. So I would now have 2 minus 4 will now give me plus 2 molecules of water plus 2 hydrogen bromide SO2 plus I have hydrogen plus and 4 hydroxide ion, which not supposed to be, because these are possible mistakes you can do when solving redox reaction. Because during this process I have 4 hydrogen ion and I have 2 hydrogen ion and I didn't cancel out. So in case if you meet this scenario in some cases and you don't feel like cancelling your book, you're going to go ahead and add these two hydrogen plus 2 molecules of water plus 2 hydroxide ion, which will now give me 2 molecules of water, remaining 2 hydroxide ion. I hope you understood. So water will cancel water, leaving us with SO4 plus 2 hydrogen bromide plus SO2 plus bromine plus 2 hydroxide ion. This question, what are we going to do? First, let's take our nitrogen. So notice that I have 1 oxygen, so I'm going to add 2 molecules of water. So since I have this and I also have this and also have 2 molecules of water, so I will add 4 hydrogen ion, because there is 2. So here I have 4, here I have 4, here I have 1, here I have 1. Oxygen I have 3, oxygen I have 3, so the equation is balanced. So here I'm now going to add plus 3 electron. Adding 3 electron, look at what we are going to have in order to balance the equation. What happens to the peroxide? I have my oxygen, so here I'm going to introduce my 2 hydrogen ion. Because the equation balance, I have to. So yeah, the equation is balanced. So I'm now going to add how many electrons? 2 electrons to this side. So if you observe carefully, I have 2, I have 3, and they're in opposite side. So I'll multiply this equation here by 3 and multiply this equation here by what? 2, in order to what? Balance it. So multiplying this equation by 3, I'll have S2O2, which will now give me 3S2O2, which will now give me 3O2 plus 3 times this will give me 6 hydrogen ion plus 6 electron. So 2 here will give me 8 hydrogen plus 2 in nitrogen will give me 2 nitrogen plus 2 in 3 electron give me 6 electron. It give me 2 NO plus 2 times 2 will give me 4 H2O. So this is what I need for this equation. Since what we need, we now have it, so I'm going to just cancel out, and is there anything else? And in cancelling out, we have 8 and we have 6, so this 6 will cancel remaining what? 2. So in writing this equation, I wanna have 3H2O2 plus 2 hydrogen ion, because 6 with minus 8, plus 2N 2NO3 minus, which will now give me 3O2, hydrogen minus 6 is cancelled, plus 2NO2 plus 4H2O. So since I have this equation, I will further balance the equation. So to do this equation is balanced in acidic medium. So to balance it in basic medium, I'll add 2 hydroxide ion. So adding 2 hydroxide ion, the 2 hydroxide ion will react with water. Will react with 2 hydrogen ion to form 2 molecules of water, plus 2NO3 minus, which will now give me 3O2 plus 2NO plus 4 molecules of water plus our 2 hydroxide ion. I hope nothing here confuse you, because the 2 hydroxide ion will react with 2 hydrogen ion to give us 2 molecules of water. So I have 2 molecules of water, I have 4. So I'll subtract minus 2 molecules of water and minus 2 molecules of water from 4 and 2. So I'll now have 3H2 hydrogen peroxide, and 2 molecules of water will be out. I will now have this, and I will now have 3 molecules of oxygen plus 2 molecules of this, and 2 out of this will now give me 2 molecules of water plus 2 hydroxide ion. Since I have this, let's check whether our charge is balanced. So our charge I have -2, and our charge I have -2. So our equation is balanced. If we check other things, you see that is also balanced. So this equation is for you. Try doing this one. Find, so that I'll ask you up to 5 questions in this. So in this question, I'm going to do up to 5 things for me, and make sure you drop it in the comment section below. We are going to find the oxidizing agents. You are going to find the reducing agents. You are going to find the one that undergoes oxidation. You are going to find the one that undergoes reduction. And we are going to balance it in acidic medium. And also, we are going to also balance it in alkaline medium. So I ask you 6 questions, and I'm expecting this answer in the comments section below. So this is all I have for you. Thank you for your time, and don't forget to like and subscribe for more videos like this on Sagacious Learners.